Hello! In this presentation, I will show you how to construct and test a multiple linear regression model with SPSS. I advise you to work along with me on the SPSS database called Adolescents Behavior 3, which is attached to this course. If you want to learn more about the basic principles of this procedure, you can enroll in another course of mine on this platform called Introduction to Statistics for Non-Mathematicians. So, let's begin. The objective of our analysis will be to find out if the linear model composed of income, academic performance, self-esteem and well-being significantly predicts the involvement in non-formal activities with colleagues and which is the predictive value for each predictor. I will select Analyze, Regression, Linear. In this new window, you can see in the left side the list of all the variables from our database. In the right side, you can see two areas, one dedicated to dependent or criterion variable and one dedicated to independent or predictor variables. So, I will introduce the total non-formal activities as a dependent variable and the academic performance, the self-esteem, the well-being and the income as independent variables. As you can see below the independent variables area, we have the option called method, which is enter by default. This means that our variables are simultaneously introduced in the model. I will keep the option enter in this presentation because we test the simultaneous model here. The other available options will be discussed in the following presentation where we will test hierarchical models. From the Statistics button, I will choose Estimate, Model Fit and Collinearity Diagnostics. I will click Continue and OK. Now, let's see the results. In the second table, called Model Summary, we have the correlation of our linear model with the criterion variable, named with the capital letter R. As you can see, the linear combination of our four predictors has a correlation of 0.20 with the involvement in non-formal activities. On the next column, we have the R-square, also called the coefficient of determination, which multiplied by 100 indicates what percentage from the variance of the involvement in non-formal activities is explained by the linear combination of our four predictors. In our case, we can see that our model explains 4.2% from the variance of non-formal activities involvement. Next, we have the adjusted R-square, which is adjusted for the number of predictors. As you can see, this value is 0.04, which is very close to the unadjusted value. We have also the standard error of the estimate, which in our analysis is not necessarily of high interest. In the third table, called ANOVA, there is another way of expressing how good our model is. As I have already explained in the previous presentation, the F value is the ratio between the explained variance, which is R squared, and the unexplained variance, which is 1 minus R squared. If this F value is significant, which means a p-value smaller than 0.05, it means that we have a significant predictive model. In other words, our linear model containing the academic performance, the self-esteem, the well-being and income as predictors is a better predictor for the involvement in non-formal activities than the mean value. In our case, the p-value is less than 0.05, so our model is significant. In the fourth table, we have the coefficients for our model. First, we can see the unstandardized coefficients of regression, their standard errors and also their standardized versions. The unstandardized value for the academic performance is 0.003, which means that when the academic performance increases with 1 unit and controlling for the other predictors, the involvement in non-formal activities with colleagues increases with 0.003 units. The standardized coefficient, which is 0.057, has the same interpretation, but its unit of measurement is the standard deviation. When the academic performance increases with 1 standard deviation and the other 3 predictors are statistically controlled, the involvement in non-formal activities increases with 0.057 standard deviations. The coefficients for the other 3 predictors should be interpreted in a similar manner. When the self-esteem increases with 1 unit and controlling for the other predictors, the involvement in non-formal activities with colleagues increases with 0.028 units, and when it increases with 1 standard deviation, the criterion increases with 0.055 standard deviations. When the well-being increases with 1 unit and the other 3 predictors are statistically controlled, the involvement in non-formal activities with colleagues increases with 0.091 units, and when it increases with 1 standard deviation, the criterion increases with 0.16 standard deviations. As far as the income is concerned, as you can see, the value of the unstandardized regression coefficient has a rather bizarre form. This happens when the value is very small. I will not get into mathematical details, but by double-clicking on the table and double-clicking on that cell, you can see the actual value, which in our case is 0.000096. So this means that when the income increases with 1 unit and the other 3 predictors are statistically controlled, the involvement in non-formal activities with colleagues increases with 0.000096 units, and when it increases with 1 standard deviation, the criterion increases with 0.024 standard deviations. So, by comparing the standardized versions of our predictors, we can conclude that well-being has the highest predictive value, while the income has the lowest predictive value. The table also includes the t-test for each regression coefficient, and this test computes the probability of having a 0 value for each regression coefficient in the population. As you can see, this probability, which is the p-value or the level of significance, is smaller than 0.05 for academic performance, self-esteem, and total well-being, which means that these predictors are actually significant predictors. The p-value for the income is higher than 0.05, which means that the income is not a significant predictor for the involvement in non-formal activities. The same table also includes the collinearity statistics. Collinearity refers to a high correlation between predictors, which means that the predictors are redundant. Ideally, our predictors should be independent from each other, which means uncorrelated among them. The diagnosis for collinearity in our case is presented in the last 2 columns of the table, called tolerance and VI phi, which comes from variance inflation factor. The tolerance is 1 minus r squared. A small tolerance value lower than 0.1 indicates that the variable under consideration is almost a perfect linear combination of the independent variables already in the equation, and that it should not be added to the regression model. So the tolerance should be higher than 0.1. The variance inflation factor, VI phi, measures the impact of collinearity among the variables in the regression model. The variance inflation factor is 1 divided by tolerance, and it should not exceed the value 10. In our case, as you can see, all our predictors have a tolerance above 0.1 and a VI phi lower than 10, which means that collinearity is not a problem for our model. If in other models we have collinearity problems, the usual solution is to remove the redundant predictor from the model. So, briefly, these were the main procedures for performing a simultaneous multiple linear regression with SPSS. Don't forget to leave a review and see you in the next presentation.